students have successfully communicated their research work with him. He has received Best Paper and Best Presenter awards in the Antalya, Turkey 2018 and the Kuala Lumpur, Malaysia 2017, respectively. He was also visiting professor at Jiangsu University, China, and Zhejiang University, Korea. He is also recipient of different projects in the PI and co-PI position. Please join me in welcoming Professor Mohammad Ramzan. Welcome.
Thank you very much for inviting me to present my work to this summer consortium. This certainly be a great platform for sharing knowledge and information in the form of a variety of positions. And this will certainly be helpful to the scholars who are looking for a paved path for their future goals. I also thankful to the summer school organizers for providing me this platform to share my knowledge. So let's start. The topic of today's presentation is the nanofluids, its inception and the development. Now, the first thing is what the nanofluids are. Nanofluids are a new class of technology-based heat transfer fluids obtained by dispersing and stably suspending nanoparticles with typical dimensions ranging from 1 to 100 nanometers. Why? The goal of nanofluids is to achieve the highest possible thermal properties at the smallest possible concentrations by uniform dispersion and stable suspension of nanoparticles in the host fluid. To achieve this goal, it is vital to understand how nanoparticles enhance energy transport in liquids. If we talk about the application range of the nanofluids have great potential in transportation to improve automotive and heavy-duty engines cooling rates by increasing the efficiency, lowering the weight, and reducing the complexity of the thermal management systems.
Yeah, I'm sorry, Professor Mohammed. We noticed your PowerPoint can't turn over. Yeah, maybe you need to make some adjustment.
Your PowerPoint is.
Yeah, we can just only see the first page of your PowerPoint.
First page?
Yeah.
It's not turning over. Just hold on,
yeah.
please. Let me check.
Okay.
Sorry.
Yeah, okay. The first page, right?
Yeah.
The second, yeah, the first one.
Let's check now, please.
Yeah.
Is it fine now?
Yeah, okay, no problem. Yeah.
Now?
Yeah, okay. It's normal. Thank you.
Okay, now. Thank you very much. Thank you. We were talking about the application range, the nanofluids. According to different researches, the application of the nanofluids in industrial cooling will result in great energy savings and emissions reductions. You can say for the United States industry, the replacement of cooling and heating water with nanofluids had potential to conserve 1 trillion BTU of the energy. Moreover, the magnetic nanofluids are kind of special nanofluids which take advantage of magnetic properties of the nanoparticles inside. For example, some special kind of nanoparticles shows antibacterial properties or drug delivery properties. So the nanofluids containing these nanoparticles may show relevant biomedical properties. So we'll see in the upcoming slides that how nanofluids are affecting our lives. If we talk about the preamble, there's common fluids such as water, ethylene glycol, and oil play an important role in the heat transfer in many industrial processes such as power generation, heating or cooling processes, chemical processes, and microelectronics. These fluids, you can say the water, the ethylene glycol, the oil, which we name as the base fluids. These have the relatively low thermal conductivity and thus cannot reach high heat exchange rates in thermogenic devices. So a way to overcome this barrier is to use the ultra-fine solid particles suspended in these common fluids to improve their thermal conductivity. So in actually what we do, we put the pores, the metallic particles of nano size into the base fluid to increase the thermal conductivity of these fluids. The enhanced thermal behavior of the nanofluids could provide a basis for numerous innovations for heat transfer intensification, which is the great importance to the number of industrial sectors, including the transportation, power generation, micro manufacturing, thermal therapy for cancer treatment, chemical and metallurgical sectors, as well as the heating, cooling, ventilation, and air conditioning. You can say the nanofluids are also important for the production of the nanostructured materials for engineering of the complex fluid, as well as for cleaning oil from the surface due to their excellent wetting and spreading behavior. Another application of the nanofluid, you can say, is the delivery of the nanodrugs. This is what the layout of my presentation. It will be the basic structure of the fluids, what are the fluids, the properties of the fluids, then the thermal conductivity. Basically, this is the main aspect that we are discussing of the base fluid as well the nano fluid, and the timeline of energy, how nano fluids evolve, and then obviously nano fluid, then the types of the nanoparticles, the types of the nanofluids, and features of the nanofluids, the long-time stability nanofluids, overview of some experimental results, effects of some parameters on thermal conductivity of nanofluids, the mechanism of heat transfer nanofluids, application of nanofluids, and challenges in nanofluids, such opportunities in nanofluids, and the reference. The research opportunities and nanofluids obviously will be more attracting for the newcomers which will be interested in this area. So what is a fluid? A fluid basically is a substance that is capable of flowing. It has no definite shape of its own. Both liquids and gases are fluids. Examples of fluids, you say the water, milk, petrol, honey, air. So in simple words, we can say a substance that has no specific shape and can yield easily the external pressure is called the fluid. The properties of fluids is the first one, the more you can say the main is the viscosity. Viscosity is defined as the resistance of a fluid to flow. It can offer refers to the thickness of a fluid, how thick, like honey is more thick as compared to the water. So we say that the viscosity of the honey is more as compared to the water. Then the density of a substance, the relationship between the mass of substance and how much space it takes up, means the volume. Fluids that do not mix layer themselves according to their density. Less dense fluids float on the top of more dense. As you can see over here, the oil is less dense as compared to water, so it is floating over here. So an object made from the comparatively less dense material, let's say the iron, which will have less volume than an object of equal mass made from some less substance such as water. Then the thermal conductivity. Thermal conductivity of a material describes how well the material conducts heat. To understand this, we need to learn that what is the thermal conduction. Thermal conduction basically is a phenomenon where heat is transferred from the area of the high temperature to the area of the low temperature due to the motion of the constituents of a substance, such as atoms, molecules, free electrons, while the object itself does not move. Thermal conductivity, in simple words, we can say is the ability of a material to conduct heat, how much the heat the material can conduct. This is what the thermoconductivity. The factors that affects the thermoconductivity, that is the material, what kind of the materials that we are discussing, the kind of the material being used in the thermoconductivity can affect the rate of energy flowing between the two regions. From the left side, let's say if the heat is moving from the left to the right, then we say that the material, if the material is, let's say, more conductive, then the heat will transfer more rapidly, otherwise it will be at a slow rate. And the length of the material, obviously it will also is a main factor affecting the thermoconductivity. And then the temperature difference between the ends of the material, let's say the one end and the other end, is the difference. And then the cross section type, obviously if the small cross section, the heat will flow more rapidly, and if the bigger cross section, it will be a little slower. So in simple words, you can say the solids have the more thermal conductivity than the liquids, and liquids have the more thermal conductivity than the gases. So if we talk about the timeline of the emergence of the nanofluids, so basically in 1981, in America, the Tuckerman introduces the microchannel technology, and later in 1985, a CUNY National Lab in the United States start program to develop the advanced fluids. And this, you can say, the journey continues till in 1993. The Mosada et al. Measured the thermal conductivity and the viscosity of 3 different water-based suspension containing aluminum oxide, titanium oxide, and silicon oxide nanoparticles. And they reported that the both thermal conductivity and the viscosity of the water become greater than before adding the nanoparticle. This was a big success at that time in 1993, that they have found this result, that when we insert the oxides or the nanoparticles into the base fluid, their thermal conductivity is enhanced. This journey continues, and you can see in 1994 to 97, a proposal leads to the funding for the first nanofluid project. And then in 1995, Choi presents a seminal paper on the concept of the nanofluids. And in, you can say, year 2000, the President Clinton announces the National Nanotechnology Initiative. And this was the, basically they have recognized at this stage the effectivity of the nanofluids. The concept, based on the concept of nanofluids, a CUNY thermal scientists have developed an advanced cooling technology. The advanced cooling approach relies on many microchannels consisting of long, narrow slits and coolants containing nanometer-sized metallic particles. In other words, the innovative process implies microchannels filled with the metallic nanoparticles laden coolant to extract heat faster than the present technology. So this was a big step that they have jumped up, and this basically the year 2000 was, you can say, was the start of, you can say, of the nanofluids. Then in 2007, the first single theme conference on the nanofluids was held, and this was you can say, made base for the now today's search on the nanofluids. So basically, it is not as old. It's you can say from 2000 onwards, it's 22 years, and if you talk about the proper start of the nanofluids evolvement, it starts from the 2007 onwards. So nanofluids, basically the mixing of the nanoparticles into the base fluid. You can see over here. The nanoparticles used in the nanofluids are typically made of the metals, oxides, carbides, or carbon nanotubes. And the common, the base fluid that we use are the ethylene glycol, water, and the oil. So base fluids, you already we have discussed as the water, the organic liquid, or the oil. The nanoparticle size is 1 to 100 nanometer size. Now, how small this one, you can imagine from here that the diameter of Earth divided by the diameter of the soccer ball is almost equal to the diameter of the soccer ball to the diameter of the nanoparticles. You can see how small you can imagine from here. So one can size it is human hair is about 80,000 nanometer wide, and a blood cell is about 7,000 nanometer wide. So you can imagine the size of the nanoparticles. Here, this may give you more good picture. Here you can see the ant is about 10 millimeter, and then a single grain of the salt you can see is a 0.3, and then onwards you can see over here this the nanometers with the carbon nanotubes. You can see over here there's a 3 to 50 nanometer size over here. So you can well imagine this size over here. The nanoparticles already told that there may be of aluminum oxide, zinc oxide, silicon, copper oxide, gold, copper, or carbon nanotubes. So here is a comparison of the thermal conductivity at the room temperature. You can see the base fluids normally do have the thermal conductivity very less. Let's say 0.63 for the water, the line 0.23, and for the engine oil is 0.14. And as far as the metallic solids, you can see over here silver, copper, aluminum is much higher as compared to this one. And for the diamond, you can see over here. So when these particles are inserted into the base fluids, their thermal conductivity is enhanced. You will see similar. You can see over here. This is these are the base fluids, the water, line, and the metal, and these are the thermal conductivity of the copper, aluminum, and the zinc and nickel and the rest of the materials. So you can see a comparison of the thermal conductivity. So the most fascinating, you can say, amongst the nanoparticles is the carbon nanotubes, and these are made from the graphene sheet. What's the basically the graphene sheet is used for the let's say anti-corrosion coatings and paints, effective, efficient and precise sensors, faster and efficient electronics, flexible displays, efficient solar panels, faster DNA sequencing, drug delivery, and more. Pricing of the graphene powder ranges from United States, you can say $50 to $200 per kg, is rather a little costly, depending on the quality and the volume of the purchase. Despite the graphene being remarkably thin, it is strong enough to protect from a bullet, according to the statement describing the newsletter. So it's had the extraordinary qualities as far as these graphene sheets are concerned. So here are the sheets that are made from the graphene. The first type is named as the single wall carbon nanotube, and the other one is named as the multi-wall carbon nanotube. A sheet of graphene of one atom is thick, is rolled into the tube like this one over here. You can see this creates a single wall carbon nanotube. The method involves combining a metal catalyst with carbon containing reaction gases, and as a result, the carbon nanotubes are formed on the catalyst within a furnace, and these are being formed in the, you can say, the high temperature of the furnace. So these are, you can see the characteristics of the carbonate is the stiff as diamond, as 1/4 in the density of the steel, at 10 times stronger than the steel. Thermal capacity is 20 times more than steel. Carbon nanotubes are elastic and a good conductor of heat, possess good electrical conductivity, possess resistance to the corrosion. And you can see that the bicycle frames, tennis stackers, hockey sticks, bulletproof jackets are being made from these graphene sheets. By use of carbon nanotubes, weight of the aircraft is reduced by 30%. It's a big achievement. You can see over here the carbon nanotubes are used in electronic gadgets minimization. You can see the gadgets that we are using on daily basis are getting smaller and smaller, and these are because of the small gadgets that are being used into these electronic devices. And in these gadgets, basically the graphene sheets are being used. So instead of the other uses, instead of wearing the vest made of the steel panels, people would start to increase their usage of carbon fiber bulletproof vest. Carbon fiber is not only stronger than the steel, it also lighter. This is because carbon fiber is very durable and also very, you can say, rugged as a material, and is capable of stopping bullets shot at an individual. A recent research at the Tsinghua University at Beijing has developed a fiber that they say is so strong that it could even be used to build an elevator to space. And they say it's just 1 cubic centimeter of the fiber made from the carbon nanotube would not break under the weight of 160 elephant weights, around 800 tons. You can say. Even you can say with the one thread of this carbon sheets, you can lift up an elephant. It's so stronger. So carbon particles, type nanoparticles may be of the zero dimension, has no, you can say the length, breadth, and the height is fixed at a single point. For example, that carbon dots, and the one dimension where only one parameter, that is length or breadth, will be entertained. And the examples are the carbon nanotube, the carbon dots, or the carbon nanowire. And two-dimensional, that's the breadth and the length, we can say the nanofilms and the nanocoatings, and the three-dimensional, obviously the crystals. So here you can see their formation in the form of the pictures. There's a zero dimensional, one dimensional, two dimensional, and three dimensional. So shapes of the nanoparticles may be like different. You can see the spherical, the needle, the octahedral, the cluster, fluted, flower, triangular, because almost of every type, every shape that we can imagine. So basically, it is you can say every shape has different characteristics. Like we can say that the plated shape nanoparticles carry maximum velocity, whereas the brick shaped nanoparticles are the best to enhance the thermoconductivity, and the spherical nanoparticles are the good option for the drug delivery. So preparation of nanofluids. Nanofluids basically are not simply by adding the nanoparticles into the water or the base fluid and stirring the mixture. Similar mixing lights we do in sugar and tea, but rather the formation of the nanofluid requires special physical and the chemical processes in order to produce the uniform and efficient dispersion of the particles for the long-term applications. So it's not simply to just mix the nanoparticles into the base fluid. Nanofluids can be produced by two methods. The first one is the one-step method, and the other one is the two-step method. In one-step method, the single step, in the single step, simultaneously makes and disperse the nanoparticle directly into the base. The both steps, mean the making and the dispersion at the same time. In the other one, the two-step method start with the producing the nanoparticle first and then dispersing into the fluid. So here is the pictorial diagram. You can see this is a single step, and simultaneously making and the dispersing the nanoparticles into the base fluid. And here is the first the base production and then adding the base fluid. Two-step method is most widely used method for the preparing nanofluid. And we can say that during the two-step method, the produced nanomaterials are directly dispersed into the base fluid with the help of the dispersing device, such as magnetic stirrer, homogenizer, or by using ultrasonic devices like ultrasonic bath, ultrasonic processors. So you need to use some machinery at the high temperature to make the nanofluids. Here you can see some experimental results that how when the nanoparticles of different types are added to the base fluid and how much you can see the increase in the thermal conductivity. And this is basically the application where these are being used. These are the live application that I'm telling you, that the ferrous oxide merged with the water increases the thermal conductivity by the 70%, and these are being used in the hybrid power engine. And similarly, the multi-wall carbonate used in the polyethylene oil increases the thermal conductivity by 160%, and these are being used in the air conditioning. And as you can see over here, the application in the mini channel heat sink, vehicle thermal management, and vehicle thermal management, you can see the 12%. This gives you the 12%. These are the basically different experiments. 1% do this and give the experiment that result, 12% increase, another one with the different nanoparticles, and they will give you 30% increase. Here is another, you can see taken from another paper, this enhancement in thermal conductivity. You can see the 40%, 45 like this one, and these are the particles, and these are the phase fluids. And this is the size that has been used, and this is the volume fraction of the nanoparticle that's been used to make the mixture. And these are the basically the papers that we have taken. And you can see from here that how much when the copper and ethylene glycol with the nanoparticles of 10 meter size and the 3% of the copper oxide is being added to this one, so you get 40% increase in the thermal conductivity, and rest you can see over here as well. So the parameters that affect the thermal conductivity and fluids is basically includes the volume fraction, how much we pour the amount of the nanoparticles into the fluid, the size of the obviously the particle size, the particle shape, as earlier told that the brick shape, plated shape, the star shape, there are spherical, there are so many more shapes. Particle material, what kind of the particle that we are being using, the base fluid, obviously, the temperature at which the experiment is being conducted, and the effect of the acidity, that is pH potential of the hydrogen. These all parameters affect the thermal conductivity of the fluids. Here you can see the volume fraction, that if we say that the 6% volume fraction of the copper oxide nanoparticle in the distilled water suspension resulted in an increase of effective thermal to 1.52 times than the pure distilled water. So insertion of the copper oxide with the amount volume fraction of 6% will increase 1.52, you can say, times the as compared to the simple distilled water. In another experiment, pure distilled water and the 10%, if the increase 10% of aluminum oxide nanoparticle, it increased the 1.3 times than the original if it distilled water use at the normal temperatures, 34 degrees Celsius around. This is the effect of the particle size. The smaller particle has the higher thermal conductivity, effective surface area increase as the particle size decreases, and increment due to the Brownian motion, and then the effect that the exponential increment as the size getting smaller. So if the size is getting smaller than the particle size, and then this will affect the thermal conductivity of the nanofluid, and then affect the obviously the particle shape as well. As I told you, the plate shaped nanoparticles carry the maximum velocity. The brick shaped nanoparticles are the best to enhance the thermal conductivity, and the spherical are the best for the drug delivery. And then obviously the temperature of the temperature at which the experiment is being conducted is also one of the factors that is affecting the thermal conductivity of the fluid. A temperature increment reduces the viscosity of the nanofluid, promote Brownian motion, same volume fraction, highest thermal conductivity, and highest temperature. 7 to 10% increase increment for the temperature range from 28 degrees Celsius to 35. If we increase the temperature from 28 to 35 degrees Celsius, the increment in the thermal conductivity will change from the 7% to the 10%. And the effect of this obviously is the same one. Temperature is another graph showing the effect of the temperature on the nanofluids. Now, if we talk about the features, the characteristics of the nanofluids, that the higher, obviously, the heat conduction at the large surface area, which allows more heat to conduct, the stability, the problem of the sedimentation is solved because of the particles are small, they weigh less, and thus the chances of sedimentation are very less. Earlier, the millimeters or the micrometer particles were used to enhance the thermal conductivity of the base fluid, but with the invention of the you can say using the invention of the nanoparticles, this stability problem has been resolved up to some extent. And then the reducing the chances of the erosion. Nanoparticles are very small, hence the momentum they impart on the solid wall is very small. This reduced momentum reduces the chances of the erosion of the components such as the heat exchangers, pipelines, and pumps, and they reduce the pumping power. In case of the nanofluids, the required increase in pumping power will be moderate. Now, effect of the Brownian motion mechanism of the heat transfer in nanofluids. The Brownian motion is the random motion of the particles expanding in a fluid. This random motion transports energy directly by the nanoparticles. So basically, this is the function that is being conducted when the nanoparticles are poured into some liquid. So clustering of nanoport result in fast heat transport along relatively long distances. When the nanoparticles are clustered, so heat travel more rapidly. So interfacial layer effects around the nanoparticle, liquid molecules are known to form ordered layer structure at solid surfaces, and these interfacial layers have different thermophysical properties from the bulk liquid and solid particles. Because of the ordered structure of the nanolayer, it have higher thermal conductivity than the bulk liquid. So coming to the more, can say the interesting aspect of to the audience, there's the application of the nanofluid. You can see the storage of the fossil fuels and environmental considerations motivated the researchers to use alternative energy sources such as the solar energy. Therefore, it is essential to enhance the efficiency and the performance of the thermal system. So, nanofluids are being used in the solar panels to enhance its efficiency. In the antibacterial activity, antifungal application, sometimes of the nanoparticles can be used as antibacterial activities or drug transmission properties. It is observed that the surface modification of the hematite nanoparticles that make them suitable for the antimicrobial applications as well as for other biomedical studies. Despite the continuous improvement of the fungal targeted approaches, a considerable number of therapy associated obstacles, including poor penetration of some drugs and development of drug resistant strains, limit the effectiveness of the fungal therapies. This ever-growing amount of research demonstrates that a large part of these limitations might be overcome using new nanotechnology-based agents and strategies. To date, a variety of nanomaterials, including biodegradable polymeric and copolymeric based structures, metallic nanoparticles, metallic nanocomposites, and lipid based nanosystems have been thoroughly investigated and presented as innovative antifungal agents. A substantial advantage of the nanomaterial focused therapies is the possibility of administration of these agents through oral, nasal, parental, and intraocular routes, which are possible due to small size of the nanoparticles. Indian cooling, one of the, you can say, the innovative technologies is used to enhance the heat transfer in an automotive car radiators by using a new type of the coolant, which is called nano coolant. In few countries, you can see the temperature goes down below 0 degrees Celsius, wherein nano coolant, ethylene glycol or ethylene family is used as a base fuel with nanoparticles because the freezing point of the ethylene glycol is minus 12 degrees Celsius. So fluids are quite effective in the countries, not nanocoolants are quite effective in the countries for the automotive when the temperature is below the 0 degrees Celsius. In the industrial cooling, if we talk about, in one of the project that employed nanofluids for industrial cooling that could result in great energy savings and result emissions reductions. For United States industry, the replacement of cooling and heating water with nanofluids has the potential to conserve 1 trillion BTU of energy. For the United States electric power industry, using nanofluids is closed loop cooling cycles could save about 10 to 30 trillion BTU per year, which is almost equivalent to the annual energy consumption of 50,000 to 150,000 households. The associated emissions reduction would approximately 5.6 million metric tons of the carbon dioxide, 8,600 metric tons of the nitrogen oxides, and 21,000 metric tons of the sulfur oxide. So nanofluids are also used in the aerodynamics part in looking for the ways to improve the aerodynamics designs of the vehicle, and subsequently the fuel economy. Manufacturers must reduce the amount of energy needed to overcome wind resistance on the road. At high speed, approximately 65% of the total energy output from a truck is expended in overcoming the aerodynamics drag. This fact is partly due to the large radiators in front of the engine positioned to maximize the cooling effect of the oncoming air. The use of the nanofluids as coolants would allow for smaller size and better positioning of the radiators, owing to the fact there would be less fluids due to the higher efficiency. Coolant pumps could be shrunk and truck engines could be operated at high temperatures, allowing for more horsepower while still meeting stringent emission standards. Cooling of the nuclear reactors. Many water-cooled and nuclear power systems are CHF-based, but the applications of the nanofluid can greatly improve the CHF, the coolant, so that there is a bottom line economic benefit, which will which also while also raising the safety and standard of the power plant system. Another possible application of the nanofluids in nuclear system is the elevation of the postulated severe accidents during which the core melts and core ends and reliquates to the bottom of the reactor vessel. If such accidents were to occur, it is desirable to retain the molten fuel within the vessel by removing the decay heat through the vessel wall. This process is limited by the occurrence of CHF on the vessel outer surface, but analysis indicates that use of nanofluids can increase the in-vessel retention capabilities of the pneumoreactors by 40%. A principal limitation on the developing smaller microchips is the rapid heat dissipation. However, nanofluids can be used for liquid cooling of computer processors due to their high thermal conductivity. It is predicted that the next generation of the computer chips will produce localized heat flux over 10 megawatt per meter square with the total power exceeding 300 watts. In combination of thin film evaporation, the nanofluid oscillating pipe cooling system will be able to remove heat fluxes over 10 megawatt per meter seconds per meter square and serve as the next generation cooling device that will be able to handle the heat dissipation coming from new technology. Nanofluids are also being used in the defense system. The number of military devices and systems required high heat flux cooling to level the tens of the megawatt per meter square. At this level, cooling of the conventional fluids is challenging. Examples of the military applications include the cooling of the power electronics and directed energy weapons. Directed energy weapons involve high heat fluxes more than 500 to 1000 watt per centimeter square, and providing adequate cooling of them and associated power electronics is a critical need. Nanofluids have the potential to provide the required cooling in such application as well as in the other military systems, including military vehicles, submarines, and high-power laser diodes. In some cases, nanofluid search for defense application includes multifunction nanofluids with added energy storage or energy harvesting through chemical reactions. Nanofluids are also being used in the cooling and heating of the buildings. Various nanofluids can be applied in conventional heat exchangers used in the buildings. Analysis shows that the nanofluids application could result in the volumetric flow reduction, reduction in the mass flow rate, and pumping power saving. Nanofluids also require smaller heating system in order to be capable of delivering the same amount of thermal energy, thus reducing the size of the initial cost of the equipment. This will reduce the release of the pollutants to the environment due to the reduction in the power consumption and the waste produced at the end of the heat transfer system life cycle. In cooling systems, nanofluids can be used in place of chilled water, which is commonly used in the coils of the air conditioning ducts. Nanofluids, you can see these can be used in the cameras and microchips. A new study has demonstrated that the liquids embedded with the nanoparticles show enhanced performance and stability when exposed to the electric fields, which would lead to new types of the miniature camera lenses, cell phone displays, and other micro-scale fluidics devices. This study reported that this type of the study may open up a new vista for using nanofluids in the microscale and nanoscale equator device applications. Application the chillers. Many reported that the 40% increase in the thermal conductivity for 0.4% volume fraction of the nanofluid. This gives an opportunity for improving the performance of the chiller in air conditioning system. Surprisingly, the cooling capacity of the nanofluids could be increased by 4.2% at the standard rating conditions. At 6.7% increase in the capacity was encountered at a flow rate of 60 liters per minute. Medical applications, nanofluids and nanoparticles have many applications in the biomedical industry, but there are some side effects in the traditional cancer treatment methods. Iron-based nanoparticle could be used as delivery vehicle for drugs or radiation without damaging nearby healthy tissues. Such particles could be guided in bloodstream to a tumor using magnetic external to the body. Nanofluids could also be used for safer surgery by producing effective cooling around the surgical regions and thereby enhancing the patient's chance of survival and reducing the risk of organ damage. Magnetic nanoparticles in biofluids can be used as delivery vehicles for drugs and radiation, providing new cancer treatment techniques. Magnetic nanoparticles absorb much more power than microparticles in AC magnetic fields tolerable to humans. Nanoparticles are more adhesive to the tumor cells than normal cells. Therefore, magnetic nanoparticles excited by an AC magnetic field is promising for the cancer therapy. There is a new initiative which takes advantage of several, you can say, the properties of the certain nanofluids to use in cancer imaging and drug delivery. This initiative involves the use of the iron-based nanoparticles as delivery vehicle for the drugs or radiation in the cancer patients. Magnetic nanofluids are to be used to guide the particles up to the bloodstream to the tumor with magnets. It will allow doctors to deliver high local dose of drugs or radiation without damaging nearby healthy tissues, which is a significant side effect of the traditional cancer treatment method. In addition, magnetic nanoparticles are more adhesive to the tumor cells and then the non-malignant cells, and they absorb much more power than the microparticles in alternating current magnetic fields tolerable in the humans, and they make excellent candidates for the cancer therapy. Results of some studies you can see over here. Here is the gold and the model test tube experiment, and this is the treatment type photothermal hypothermia, and you can see the result is 70 to 80 per degree Celsius threshold reach easily good particle density. And these all are the medical, you can say, and the applications. And these are effective, and you can say the magnetic hypothermia all, and this is for the drug delivery. These are, you can say, the particle types that have been used and the particles used, and these are the experiment that is done. Other than you can see those also. So basically, the nanofluids are quite effective in the medical side as well. So if we talk about the challenging in the nanofluids is the high cost nanofluids. It is marks that despite the amazing performance of the nanoparticle to solve problems, the high cost of the nanofluids utilization is always one of the most important reasons that may be hindered the application of the nanofluids in the industry. These are quite costly, and the material that we use to prepare the nanofluids. The disagreement between the most experimental data and the theoretical model of predictions. This is a major issue because nanofluids are, you can say, at their intermediate stage, you can see over here right now. So sometimes the experimental result and the theoretical results of the same type of the nanoparticles and the fluids give different results, so that may be confusing. Although the nanofluids have displayed numerous exciting potential applications, some vital hinders also exist before commercialization of the nanofluids. The following key issues should receive greater attention in future. First, further experiment and the theoretical research is required to find the major factor influencing performance of them. Up till now, there is a lack of agreement between the experimental result and the theoretical ones. So this is a hurdle. Once there is a consensus between the experiment and theoretical result, then these can be marketing, then can be commercialized and can be used at the larger scale. Difficulties in the production process. obviously the manufacturing of the nanofluids has implied either a single step that simultaneously makes and disperses the nanoparticles into base fluids, or the two-step approach that involves the generating the nanoparticles and subsequently the dispersing the particles into the fluid. Using either of these two approaches, nanoparticles are inherently produced from the processes that involve reduction reactions or ion exchange. Furthermore, the base fluids contain other ions and reaction products that are difficult or impossible to separate from the fluids. Another difficulty encountered in the nanofluid manufacturing is nanoparticles' tendency to agglomerate into larger particles, which limits the benefits of the high surface area of the nanoparticles. Stability, obviously, is one of the key factors that is challenging, hindering the widespread practical applications of the nanofluid. Generally, the long-term stability of the nanoparticle dispersion is one of the basic requirements of the nanofluid application. The stability of the nanofluids has a good corresponding relationship with the enhancement of the thermal conductivity, where the better the dispersion behavior, the higher thermal conductivity of the nanofluid. To get stable nanofluid, physical or chemical treatment have been conducted, such as an addition of the surface modification of the suspended particles, applying strong force on the clusters of the suspended particles. Dispersing agents, surface active agents have been used to disperse the fine particles of the hydrophobic materials in the aqueous solution. Then the thermal conductivity, viscosity, and specific heat models of the nanofluids are many in the different. So their readings of the viscosity, the specific heat, and thermal conductivity in different papers is different. So this also creates a difficulty for the to conduct the experiment that which should be chosen to prepare the nanofluid. So this is quite sometimes becomes confusing. So nanofluids does have a great opportunity as far as the research is concerned, because still there are you can say open-ended questions are there, that production of the nanoparticle to make them more economical, producing the nanoparticle with the more accurate size, investigation on the environmentally friendly as well as the health safe nanoparticles, determining the thermal conductivity of nanoparticles accurately. As I earlier told, there is a disparity between the experimental and the theoretical data, and this can be resolved by the more research in this area. Research on how to make the nanofluids more stable and estimation of the effective viscosity of nanofluids. So all these are the challenges and the you can say are the question open-ended question that the researchers can do in the future. So this is a great opportunity for the individuals who show interest in the nanofluids and can do a lot of work. Okay. The popularity of the nanofluids can be gauged by looking at the amount of the publication research in this core field, and still there is a more room for the publication as well. So you can say there is a big gap right now, as big as well right now, uh, to answer the question that I've shown in the previous slide. A glimpse of the number of the publications since its inception may be seen. You can see over here in the it has started, let's say 1996, and the number of papers you can say up to 2010 it was around, you can say 23,000-24,000 around over here. And if you move a little forward from, you can say 2010 to 2019, the publication manifolds over past decade, you can see reaches from 426, you can see 33,100. So there are many papers on this area, and still there is a big room for the you can say research on this. I have shown you the challenges in the area of nanofluids. So one can focus on one area, and he or she can produce many papers in this area. So research in the field at a number of the articles per year, you can see 95, and this is same data with the different graphical structure you can see over here. Yes, now there is a new type of the nanofluids which is also recently introduced, that is named as the hybrid nanofluids. Hybrid nanoparticles are defined as the nanoparticles composed of two or more different particle materials of nanometer size, and they are being poured into the simple base fluid. In nanofluid, we use only one particle, one substance, one metal, but in the hybrid, we can use two or more. Okay. So this is a new, you can say, in the recent development in the area of the nanofluids. Based on the studies, it is concluded that the thermal conductivity of the nanofluid can significantly boost it compared with the conventional fluids of the nanofluid, and boost is not linear with the concentration, but rather it is exponential. So hybrid nanofluids showed enhanced characteristics of the thermal conductivity in comparison to the conventional nanofluid. Adding hybrid nanoparticles can significantly enhance thermal conductivity of the base fluid, and the study showed that if we use two particles in some base fluid, it results more thermal conductivity, more enhanced thermal conductivity as compared to the single particle insertion into the base fluid. So there are the researches right now that the people are shifting from the nanofluids to the hybrid nanofluids. So these are the references sent from my side. So basically, there are so many, you can say, the big room available for the advancement of the in this area. So I urge the researchers, if any of one interested in this area, he or she can produce much more, you can say, the research, and they can produce the big number of papers over here. Thank you very much from my side. Thank you. And if you have any question, I can. Yes, agriculture. One of the question that can we know what can nanofluid do in the agriculture field? Yes, nanofluid are also being used in the agricultural area. You just write this thing into the Google, that the effectiveness of the nanofluid in the agriculture area. So you can find a number of applications over there. These basically, if I remember, the nanofluids can be used in the agriculture for defrosting, or in basically the storage of, you can say, the different you can say the fruits or since the nanofluids are quite effective, and even in the production of the higher production for the crops, the nanofluids are quite effective. You can right now, I suggest you to just go on the Google and just write the effectiveness of the nanofluids in the agriculture. You will find the answer of this question. The next, please, if anyone is interested in to ask the question.
Hello, any question about this lecture? One participant put down her message in the message board. Thank you so much for your presentation. For me, it's a new feed and it inspired me a lot. Thank you.
Thank you very much. Thank you.
Okay, hello everyone, and thank you for Professor Mohammed. And the next is our the second lecture of this afternoon. And first of all, I also want to introduce our distinguished lecturer, Dr. Li Meng Yixin. Dr. Li Meng Yixin, Associate Professor in the School of Architecture and Urban Planning, Beijing University of Civil Engineering and Architecture, a young scholar of Beijing Overseas Talents Program, received her PhD in Landscape Architecture, Technical University of Munich, Germany. She is a community member of Beijing Overseas Talents Association, the member of History and Theory Community and the Territorial Landscape Community of Chinese Society of Landscape Architecture, the member of Secretary of Cultural Landscape Community of Chinese Society of Landscape Architecture, and the member of China Urban Landscape Life, EUN, and the leading member of EU Collaborative Classes Industry Team of Politico di Milano, Italy. She is mainly engaged in the research and the teaching of green open space, cultural landscape, and the post-industrial landscape. Now, please join me in welcoming Dr. Li Meng Yixin. Welcome.
Hello, thank you for your introduction. I need to open my, I think the host need to give the power to me to open my video. I can't open my video to show my face.
Okay, let me check. Yeah, I'm sorry.
No problem. At first, I share my PowerPoint.
I think you can do it now. Can you test it?
Moment.
Yeah.
Okay. Okay, no problem.
Yeah, okay.
Okay, thank you very much for our university's intervention for giving this lecture about the topic resilient cities for the students at 2022 virtual summer school students. And now my topic is about resilient cities, systems of green open spaces. So before I begin my lecture, I will give a brief introduction about myself and my educational background and also the university. I got my PhD at the Technical University of Munich in Germany. And after that, I become a teacher at the University of Civil Engineering and Architecture in Beijing. And you can also see the two cities and the two universities in this picture. This shows the beautiful cities as well as the beautiful universities. So the next one is, as a teacher, my background is landscape architecture and urban planning. So I give the courses at our university, not only for our Chinese students, but also for the international students, One Belt and Road students, especially in our Belt and Road international program, supported by our university. And you can see I take our international students to visit some special places to get the knowledge, especially in the the Museum of Chinese Gardens and Landscape Architecture, as well as the Beijing Planning Exhibition Hall. And in my course class, I teach the students how to recognize the landscape and also how to know the cities, the contemporary cities, from the perspective of landscape architecture. And also in the class, I will show them how to design, and they will very interested in how to design the landscape, and also give some sketch and discussions in our class. As not only these activities, teaching activities, I also invite the Professor Luca Maria Francisco Fabris in the first day. He also gave the lectures to us, very perfect lecture. And he also, as a professor for our university, we together to organize many workshops, and these workshops also give the students many knowledge and lectures. And also we visit some places such as the Shougang Industrial Park, for letting the students to know what is really the landscape architecture in the Chinese urban regeneration. And also we, the last year we built the collaborative classes with Politecnico University Milano, and our students with the students in the Polyme together to share one class, and our students have the positive ways to observe and to see the landscape in Milan and also in Beijing. So the next, we also have some workshops, design workshops in our university. I have mentioned, and learning by filming, and also the International Landscape Architecture Design Workshops is organized by us. And not only that, we have also to organize the students to join in the landscape architecture design competition, Park City, and the Garden of Future. The students under our guidance to design a bamboo garden, and also really built in Chengdu their work. They are very positive. In our positive way, we teach the students how to know the nature, the world, and the landscape, and also to implement how to construct the gardens. So I have mentioned many. Anyway, in a word, I hope the students, no matter from the foreign countries and from the China, can have the opportunity to join in our university. You are also welcome to join us. So now I will begin the lecture about the resilient cities systems of green open spaces. Firstly, I will give the brief introduction about resilience. I think maybe some students have mentioned some ideas by the professors before to give some explanations about these terms, but I want to say 4 parts surrounding this term resilience. The first part is about cities. How could we recognize the cities, or how could we think about cities? There are many words that have appeared in the professional fields, such as green cities, sustainable cities, very formal one, but these words are based on the natural crisis. The nature is conceived and found by the people. We think the nature is very useful for our cities. So the green cities and sustainable cities are proposed. Next, maybe the smart city, healthy city. That is also smart cities concentrate on the intelligence and ecological intelligence to deal with the problem that happened in the city. And the healthy city is concentrated on the people's right and the people's health. And also the next one is sponge city. Is the city is analyzed with the sponge, and also the porous cities. That is also from the structure of the cities to know how to see the cities like landscape structure. And the next one is resilient cities. I think the resilient cities is proposed based on those terms about cities. And besides that, the resilient cities has many functions, such as they can deal with the problems of the climate change, disease epidemics, and adaptation and mitigation. And so that's why the resilient cities are very important for us. The next part is about the resilient city, the related concept or the related solutions. The first one is nature. It's absolutely the nature, because the resilience is borrowed idea from the ecological meanings. So in these meanings, the ecosystems and the ecosystem service is mentioned in the emergency of the resilience. That's why we borrowed the ideas to many domains. And next is nature-based solution. That is also immediately collected with the nature. That's a solution. In briefly, that's the tool of the managers, the measures how people can use the nature-based solutions to deal with the problems that in the city. And the next one is urban landscapes. So urban landscape is our essential contents how to see, how to recognize the resilience. And the dynamic concept systems is also very important keyword for us. I will explain detailed in the later. And also the green structures. These words are connected together to explain how to give the meanings of the resilient cities. And the next one, the last one, is the resilient cities, which is used in the disciplines. That is absolutely the space-related disciplines, such as the urban planning and landscape architecture, and also the architecture. So we'll give the three contents in my lecture to explain this resilient cities dynamic system of green open spaces. The first one is about the resilient cities. First, I will briefly introduce the backdrop. How could we why we could see resilient cities is important. And then based on these backdrops, I will give the concept based on the ecological meaning. And also the qualities, 7 qualities will give you to know what is really exactly the qualities of the resilient systems. And the next one, the second part, is about the dynamic systems of green open spaces in the field of landscape architecture and urban planning. The first of all, perspective is important because we see many perspectives of resilient cities, but in our field, in the landscape field, or in the urban planning field, how could we see this word, and how could we connect the green spaces into the resilient cities to give the most influenced power? And also the method is mentioned. The landscape structure is the co-element to explain the open spaces. The third part is about landscape resilience. So based on these two contents, I will show you the 7 landscape resilience principles, and also as well as a project in the urban planning and the landscape architecture. These projects from the field of landscape is very famous, and this project illustrated how the resilient cities around the world to give the meanings of the resilient cities, or how the resilient cities can be measured by the scholars and the experts. There are 3 projects. One is from the New York, and the second is from the UK, and the last one is from Beijing, our university. We have tried the research to explain the resilient cities and give the meaning of green infrastructures. This Beijing Boulevard plan to launch a study to give the students to show the meaning of the resilient cities. And the first one is resilient cities. On the official website of the urban observatories, we could see clearly the population density. So the image shows that the metropolises around the world is growing, and more than half of the global populations live in cities, because cities are still appealing for most of the peoples, especially in China, And also, however, the cities are vulnerable because of the population density and many problems triggered by this population density. And also we can see the cities from in New York, in London and Berlin, the population densities, and also composed to this population density, we could see the green open spaces. That is very clearly shown in the map. Also, these three cities, green spaces as especially as a medium to give the city a chance to breathe. We can compare it with these two pictures. We can show this one and this one. The green open spaces like green sponge or green structures to support the city to have a good functionalities. And from this perspective, we could see the cities like the porous cities. That's why the term porous city comes from. And from the landscape architecture perspective, this structure can explain why the city needs the systems of the green open space. And these spaces are also connected with the resilient cities. So the words, but based on this image I have shown to you, actually the world city and towns are more densely populated and more interconnected than ever before. That's why we need maybe a new concept or new technologies to give the meaning. And also we require models of governance that mitigate the risk and the response to these evolving changes. No matter the city evolves constantly, the problems also compared with the city is evolving. So that's the challenges or the risk I want to show you. The first, cities have faced many risks, even though many cities in the past have demonstrated their resilience in the face of resource shortages, climate change and disease pandemics and natural hazards, especially the floods, the earthquakes and the fire disasters. This risk gave the challenges for the cities, and how could we do? And this is the main topic that around the world many experts want to explain or want to deal with. So the first of all, some foundations launched 100 resilient city initiatives to support the cities around the world to deal with these problems. They demonstrate cities themselves can deal with the problem and increasing the urban resilience in the face of these risks. And also we could come together to deal with these problems. That is the initiative that is launched by the expert. And we could also see the risk is especially served in the coastline cities. And many researchers have studied about the worldwide deltas about their urban resilience. And in China also there are some resilient cities under the initiative of these 100 resilient cities, such as Yiwu, and I remember 4 cities have joined in these initiatives. And from this pictures on the right, we could see most of the urbanizations takes place in this flood, in this lower part. So it is very easily for the city to suffer from the flood. So the resilient cities may take these programs for these cities to deal with the flood problems as a most important risk. And beside of the initiatives, we could also find some agenda about the sustainable development launched by United Nations in 2016, and also this they gave the 17 development goals to show what is the main problems for our contemporary cities as well as its development. And in the goal 11, we could find from this part in the orange one, we could find this one of the goal is making the city and the human settlement inclusive, safe, resilient, and sustainable. That is the common agenda for all of the world when the world and the city changing. And as well as this 11 goal, we could also from this goal words, there are some keywords so that we can also grasp. It is that by the 2030, we should provide universal access to safe, inclusive, and accessible green and public spaces. In the goal 11, they mentioned this part, and especially not only for the women, for the children, and for all of the urban resilient in the city to enjoy these green open spaces in the resilient cities. And based on this agenda, so we could to think these cities are regarded as complex meta systems. This system, we need to use our knowledge and use our professional tools to deal with these problems. And these problems, some tourists in architecture and landscape architecture have found in 20th century. In 20th centuries, and also some scholars, some famous scholars have mentioned these complex systems of cities. That cities can be seen as a constantly shifting, complex, and contingent environment. That's why we look at the city in a process oriented and in a complex way, and also in the decoration of the concert of the by the landscape architects, they also gave the manifestation to show what the landscape architects' task for these resilient cities. A sense of crisis have brought us together. That's the important part. We need to give our own task for these resilient cities. That is, what is merely offensive or disturbing today threatens our lives, no matter now and tomorrow. We are concerned over misuse of the environment and development, which has lost all contact with the basic processes of the nature. So the essence of the nature for the resilient city is very important. So the next one is, I want to show you from the landscape architecture, from this field, how could we see at the resilient cities? We think we need to give our power to solving the problems as well as the environmental crisis. And also this profession is the main field to deal with the dependence of the environmental processes. And also landscape should be understood. They have this power to, or they have these capabilities to let the people know where is the nature and where is the resilient city. And the resilient city is a response to the changes. And now I have given the main keyword about the resilience, the concept of the resilient. So inspired by the Darwin's, it is says the strongest of the species of that survive, not the most intelligence, but the one most responsive to change. So the change is normal, we have mentioned. So the resilient city is composed to this change. So resilience is a term that emerged from the field of ecological in the 1970s. From that, the experts want to describe the capacity of the system to maintain and recover functionality in the event of disruption and disturbances. That's the origination of these keywords, and also use this word to explain the complex systems as well as the cities constantly adapting to the changed environment. That's the process, the keywords emerged. So borrow the idea from the ecological meanings. We need to know the dynamic systematic changes is the normal thing. And related this normal one, the adaptabilities, resilience is, and the flexibilities is the three characteristics around the resilience. And in the ecological meanings, we could see the model or the dynamic circles of ecosystem development give the detailed meaning of this resilience word. And from these pictures, we can see the exploitation and the release and the conservation, and also the review have this in this process to show the ecological organisms and their relationships between each other. And also this is happened in the process in time and spaces. So we need to learn from the nature to find the ability of ecosystems to recover, to reorganize, and adapt in the field of the regular change. That's why we need to learn this word. And also the ability of resilience, that is from this resilience, there are also a keyword, recovery. Recovery is also a process of resilience buildings. We could see from this framework, disaster risk reduction in the reconstruction have a deeper tracy and also a higher endpoint. From this process, we could see the nature has their own recoveries to show this process and also to reorganize by themselves. So that's the idea borrowed from the nature and also used to the cities. So the cities have also the power to give their own abilities to recovery. And from this urban resilience, we could see that is the capabilities of the individuals, communities, institutions, business, and systems that within the cities to survive, adapt, and grow, no matter what kind of disasters. So it's a process we need to witness. And from this point of the resilience, we could see some green cities, some green ways of the systems of green open spaces has been established. An example from the German, we could see in the map some national parks, some biological diversity hotspots, and also some natural zoo Nanocludes have been built for the resilient cities. That is a connection between each other from the green open spaces. And also, if you want to know much about this part, you can see my lectures that is published by the Landscape Architecture Journal in China. And especially, we need to know the resilience goals. There are 12 goals in this resilience that also represent the qualities of resilient systems. There are 7 parts: reflective, robust, redundant, flexible, resourceful, inclusive, and also the integrated. I will give the brief explanation, because these circles is researched by the resilient city groups, but what is the specific meaning in our field of landscape architecture? I will give the connection between each other. So the reflective systems are accepting of the inherent and ever-increasing uncertainty and change in the world. And reflective is also the meaning. The people and the institutions need to examine the past and learn from the past. And this is the good way for us to know what we have did and what we should do in the future. So like this reflective ways, we could mention the China urban regeneration. That is the picture from the Beijing urban design guidelines. So we could see in China, most of the cities are reflected by the construction of the city building and the mode of the city building. So we need to give a process-oriented way and also create critical ways to rethink the city, what the city should be like, and how should we construct the cities. And also the famous examples from the reflective ways, we could mention the Amscher Park in Germany. And this system of green open spaces has demonstrated the critical reconstruction of urban landscape regeneration. That is the way in a rational, reflective, and process-oriented way. We could say in our regional systems, the green open spaces has been built for people to enjoy. And also this is the good example of resilient city part. And also if you want to know more about this, you can read my paper on the website to know much about this. And also I have mentioned the China urban regeneration. There are many models or many examples for the pilot project to give some ideas for you to know what has happened in China now. And the first page is about the defense of the park has been destroyed. You can see the people was destroying this wall, the fence, and more accessibilities could be found by the people. Before, people cannot too easily to go into the park, especially when the entrance they find. But now the wall was destroyed. So that is also the examples of the reflective reflective way to think what the green open space should be like. And there are many more projects such as Liangmahe River remodeling in Beijing, and also the Shougang Industrial Park, and as well as Jingzhang Railway Heritage. They gave the examples of the people to use the post-industrial sites to give their new life for the sites, to also to give the people's new meaning to use these places, no matter in Beijing and also in Shanghai and other cities. We could also see in Beijing the hutong, the green microwave green ways for the cities to let the hutong space more liable for the cities. So the next one is robust. We could see the robust systems in the resilient city include well-conceived, constructed, and managed physical assets, and so that we can withstand the impact of the hazard events. So in the right page, in the right pictures, we could see land as palimpsest. We could to use this land, reuse, reorganize, and find the more informations, no matter what has been built on the land. So in this system, so we could see Shougang Industrial Heritage Park has built a robust framework for the whole place. That is adaptive design, we could mention. And four important phases have been mentioned. So the remediation system of green open space, site drainage system, and the transport systems has superimposed to each other to construct this robust framework. And also three important methods has been used, such as classification, preservation, and the layer planning, and fragment palimpsest and waving have been used to specifically to organize this whole site. And also in this part with Professor Luca, we have contribute to one paper in the Landscape Architecture Journal, and more details to show what is the post-industrial areas and how the experts use the landscape method to change this size. And the third one is redundant. Redundant means to spare the capacities purposely in the city. We could find many green spaces in the city need to be reserved for the further development in the cities. That is the very important part for the system, for the building of the systems of the green open spaces, and give the city more blank and more opportunities to form the resilience. And the fourth part is the flexible. Flexible, that is very, very important. It implies the system that can be changed, can be involved, and can be adapted in response to the changing environment. And also it should be introduced by the new knowledge and technologies. We could find new ways to extend the city's flexibilities. And also we could find some important project, especially in the New York City. We could find an Austin Gambins and the reef balls were installed in the Hudson River parks. Along this park, we could find the also structures are designed in the concept of the biological dynamics, and they will introduce the biological and also to offer the habitat varieties for the river wildlife. That is the new technology to be used for the coastline cities. And the fifth part is about the resourceful. We could see the resourceful means the people and the institutions are able to rapidly find different ways to achieve their goals and meet their needs under the risk. And also that is the normal way for the foreign countries to use. And we could see from the New York Highland Park, an organization of Friends of New York has been organized. That is the representation of the resourceful. That is, shows the people can give the feelings, can give the words to decide what do you want, what do you, how could the people to use these green spaces, and how this post-industrial sites can be reused by the people, and to form a new and liable open spaces. And the next one is inclusive. The inclusive is an essential approach that contributes to a sense of shared ownership or joint vision to build cities resilience. We could say also in this part, the broad constellation and engagement of the communities, the universities, the design companies, and also the administration has been joined together to contribute to a green open space establishment. And this pilot project from Jinjiang Wudao Pilot Park pilot project, that is also the industrial heritage park. We could find the universities give the ideas, and also the design companies and administration to get together to share their information and how the site could be extended on the site. And the last one is integrated. We could say integrated is also the path for the city system to give the integrations. That is also the way we could fund the landscape systems of the green open spaces. The landscape is also the combined together, no matter from the landforms, from the transportation systems, the water systems, and so on. These integrated elements should be together to contribute to the building of the resilient cities. So in conclusion, for us, the cities are evolved constantly, that we have mentioned about, and also landscape will be decisive importance for the future development of the city. And we cannot predict the ecosystems, how could the ecosystems evolve, change, and behave, because it has a characteristic of unpredictable, and what we should do is accept and embrace the changes and find the ways to give the city flexible and responsive. And then the next part is the dynamic system of green open spaces. That is based on the first part. We need to think a question about how can we build the cities and the landscapes in a resilient ways. We have seen many green space phenomena and elements in the cities, no matter from the gardens, water system, natural landscape, and post-industrial parks, river spaces, and the traditional hutong in Beijing. But this is just the element. This is not the dynamic system of green open spaces. The green spaces is built by this element, but not only by this, it is also by the ideal of green. And this ideal of green has been demonstrated by the park image, no matter from the central parks in New York and also the green systems of Emerald Necklace. This is also the elements of the green spaces, but also what we need for, or what we should do for processing these natural green systems. That is from the resilient city, the way of adaptive design. In the Fresh Kills Park, we could also find this plan demonstrate this project that is lifescape. We could find these many phases to construct these parks, and also to give the natural process to the new idea of the park concept. And not only about that, we could also to think these green open spaces from what is landscape. Landscape is not only a model for the entire urban spatial structure, but also the open dynamic system spaces. That is the keyword I want to share with you. And the resilient structures from this concept, we could find the porous cities I have mentioned. And the porous cities is the substantial quality of a structural stabilized living environment. We could find the porous cities, that is the phenomena around us. So these porous cities without structure cannot be survived. That's why the method of structure is important. They can help the city to give the exchange of energy and matter and also the informations. That's the circle, like the circle, to give the resilient cities more energy and to give the city more powerful. And also these porous cities had also mentioned by the architects. They will also to show how these porous cities can be built in an architectural way. So the vertical parts of the building has been conceived by the designers. They want to combine the parks, the public spaces, and also the urban programs in the life to be built in a vertical way to show the potential of these porous cities. And also the porous cities can also help us to image the city. The city can be conceived by the porous cities, and also they have many characteristics to show what is the qualities about these ideas. That is interpotential superimposition, and also the layers of the spaces, as well as the integration, overlapping, and the communication of the spatial element. That is also the open spaces of the processes with the coincidence, rhythm, and the time. These three characteristics can explain the porous cities to show the importance of the structure. And also for the system of green open space, we could define the critical concept by the J.B. Jackson to explain why the dynamic landscapes is very important for us to explain the cities. So the landscape is not a sceneries. It is more than a collection, a system of man-made spaces on the surface of the earth. We could see this landscape, but the landscape is made by people. It is not only just a feature of natural environment, but also it is artificial, it is synthetic, it is always subject to sudden or unpredictable changes. That is the J.B. Jackson's conception to the urban landscapes. And also he mentioned this idea by the 1954. That's very early. And also under this idea, we could find the landscape is the organizer for the space and the time. We need to consider the space or consider the resilient city in the process of the city involvement and also in the range of space and the time, especially when we considered the coastline cities. We could find the coastal systems and their structures as also is always under the transition and the restorations. That's why we need to see the resilient cities in an evolving ways. So I have also given you two ideas that has existed in the history of landscape architecture that is related to the resilient city. One is about the mention. The landscape can be, or the ecological systems can be seen in a mechanical way, and also the organic view about the cities and the landscape to be regarded. And from these two concepts, we could see the structure and also the landscape architecture could be found in a green open spaces systems. And how could we organize, or how could we analyze these green structures? We could find the map that we have used in our research. That is also like the Noli map. It is the green Noli map to show the structure. We could see the cities has their own characteristics. We could find the pictures that is Beijing, the Xicheng district, that is very close to our universities. That is the Beihai, and also we could find the structure of the whole city, Beijing city, and the dark one is show the density of the green open spaces. And this one is the Shijingshan district. We could find the Shougang Industrial Heritage Park, and also the Yongding River, the mother river of the city, and also that shows the mountains and the systems of green open spaces. And compared with this city, we could find the Berlin in Germany. We could find in this map way the green open system spaces in Berlin could also be observed. And these structures show the ideas of how the people in the local city could find the city structures. For us, for Chinese, the system of green open spaces can be known as the Shanxi city. And this is also the traditional urban landscape in Beijing. And compared with that, we could find the Munich in Germany to show how this city was developed by the metropolitan and also from the features, waters and mountains. This is the structure. And from this, we could see in the future, the city and the landscape can be connected to know each other. What is city and what is landscape? We cannot clearly to find the boundaries, because the cities is increasingly integrated with landscape, and the constructions between the towns and the countryside will be blurred in the future. That is happened in the European cities, but also that is envisioned from the Chinese cities. And the last part is about the landscape resilience. There are many things I want to share, but the time is limited. So we could, but I gave some keynotes. So the students can maybe later to read and to show what's the meaning I want to share with you. The landscape resilience is based on the term of resilience. We could see the landscape resilience has also the ability to reflect the sustainability of the desired ecological function, and also the biodiversity and the process over the time. But also it is a system, no matter from the ecological, from social or other sectors, it is always the systems for us to consider. And so there are 7 contents I want to explain how to build landscape resilient framework. From setting, we have mentioned the setting is like the city's background. Every city has their own unique characteristics, their morphologies, their geography, and also the culture that is so different. So the setting is important. The next one is the process. we could also think the nature is a process, and so the city need to follow the laws of the natures, and also give the process of the city, and also the characteristics is about the connectivities. That connectivities give the connection to each other, no matter the process or the elements. The fourth about the diversity and the complexities. So the complexity is originated from the diversity, no matter the programs, the social program, the city, the people's life, and any others. The diversity is very, very important for nation or for cities. The next is redundancy. Redundancy, I've mentioned, is about the space blank. We could to give more room for the nature to let them involvement for the future. So the next is the skill, and the last part is about the people. The systems of green open spaces in the resilient cities is for every people to enjoy these spaces, and people have the words or have the rights to give their ideas about what they want to do or what they want to see in the resilient cities. So the next part is about the project I want to share with you. The first one is about the New York, the big U-turn. That is very famous project. That I think that's one of the first famous project I have known about the resilient cities. So the rebuilt by the design, that is a proposal for the competition to the designers for them to give the idea to show how they considered the New York City as well as the coastlines. So this has been mentioned by the big company. They have gave the ideas about how could resilient cities looks like in the first time. They give the questions for everyone. What if we could imagine the resilience infrastructure for the Lower Manhattan in a way, not to build a wall for the city, but instead they want to give the social and environmental facilities to the specific neighborhood. And also they give many measures like the toolkit to add the resilience of infrastructure into the social programs to let the people to enjoy the green open spaces and not to defend the place. So there are many forms for them to transform these coastlines. They have the many ways in the program to show their diversities. And the next project I want to show you from the UK, we could see facing up to the rising sea levels. How could we do retreat, defend, or the attack? There are three main approach for the cities to deal with the resilient cities transformations. That is also the adaptive strategies. So the first one is the retreat, is moving the critical infrastructure and housing to let the river into the cities. And the more important is how to moderate the tide and wave energies to let the people know that is a river. We need to welcome the river, but we need to consider how could we deal with this river tide transformation. That is the first approach. The second approach is defend. We could say the defend is the very normal way for us. We are familiar with. That is the insurance, the standards of the protections away from the rivers and from the floods, and also how this defense can be designed in a way that is to make them economically and commercially viable. That is a key question for the defense one. And also the attack is like the ambitious way to build out the water out. And also that is for the long-term benefits that we need to consider. And the three approach for organize this coastline is still tilt, floating structure, and the land reacting reclamations for this part to give these three ways. And also according to these three ways, we could find the master plannings. They have shows the different way, under the different ways there are different master plans for us to have the different connections between the water and the city. And the last one is about our research. And I have mentioned this, I have present this research in an international conference. That is the idea from the Healthy Street in London. And also we with the students together to research on these green ways, use the depth map, and also from three levels, from the global system level, from the mediating, and also the private levels for characteristics of the healthy systems has been built for the Beijing Xicheng district. We could find the greenways at the city, district, and also community levels to construct a system of green open spaces. So the last part is a conclusion. I will give the several conclusions about how could we consider the resilient city. The one is about working with nature to foster the resilient cities, to emphasize on the natural process in the city and also the circles. The next one is the enrichment through complexities. We need to construct the structure, diverse structures for the cities involved, as well as the green open spaces. The next one is the landscape as process. That is concentrate on the ecosystem to give the natural functions to the cities and help the cities to evolve automatically to have the landscape remains flexible, open to the new development. The next one is creative on the site. So we need to use our ideas to build the connection between the city, the people, and also the soil and the plant, the biological materials. The last one is involvement of the users. So the voice of the normal people is very important. Everyone can have the right to have the joint discussions with the publics and also with the expert, and the designers as becomes a social catalyst and also the advisors for the public. So we just help them to know more about, but the ideas can come from them. So this is the whole part of my lectures. So if you have any questions or if you want to know more about this topic or more information about our universities or the School of Architecture and Urban Planning, as well as the landscape architecture, you could give the email to me, and also it is also welcome. Yeah. Okay. Thank you.
Yeah. Thank you, Dr. Li. Such a great lecture in the green open space. Thank you. And I think our participants may have some questions, and everyone can use Q&A session to raise your questions. Okay, Dr. Li, in the QA session, there's one student asks us about assuming that there is an abandoned industrial park, transforming it into an industrial landscape does not actually have too high economic value, or in the short term, it will not bring much economic benefit. So we need to transform it into post-industrial area?
Okay, thank you for this question. But I think I want to I want to correct this sentence, because the student said the industrial landscape had not too much higher economic values. That I think I don't think so, because Shougang post-industrial landscape parks has given more economic values for the Beijing city. So we could see many shopping centers there, and also many people around the Shougang district and also inner cities want to see these landscape parks, and they will also buy many things there, and also enjoy the restaurant, and also to have the exhibition, art exhibitions there. That is also the economic values for the transformation. So, and also the tendency for the transformation of the post-industrial areas is the integrated way for us to give the city more opportunities to revival. So I think that is a good way for us to use these abandoned places. Yeah.
Yeah, thank you, Dr. Li. And any questions?
No, okay.
Okay, yeah, it seems that's all for today. Thank you, Dr. Li. Thank you again. Yeah, and then the next lecture will be held on the 8 p.m. in Beijing time, and see you there. See you.